Okay, this is lesson 2.1b. I'm here, Mr. O'Hara, and this is
Ulysses.
Ulysses is here. He's going to help me out today, and I'll be the student in the video. Okay, so the first thing we're going to start off with 2.1b is we're going to start off with a 45, 45, 90 triangle. Now, since this is a 45, 45, 90 triangle, what do I know about it? What kind of triangle is it?
Right triangle?
It's a right triangle. That's right. But what other kind? Think about the sides, because two of the sides are equal. What does that mean?
It's isosceles?
Isosceles. Okay, so take a marker.
Alright.
And if I call one of these legs, mark it as X.
Alright. So both of these are X.
So then that one's X. Good. Now what's the third side?
H?
Could be, but what does H equal is what I want to do. So we use Pythagorean theorem to find it, right? So that gives us X squared plus, right?
Yeah.
Okay. Solve it now.
So
You can come over here and solve under there.
So
What's X squared plus X squared going to give us?
X squared plus X squared is going to give us
2X squared.
2X squared.
2X squared equals
That equals.
C squared, which is what we want to find. We want to find C, right?
So we use square root.
Square root, right?
2X squared.
And close. Hold on. Back up a little bit. Equals. Oh yeah, there you go. There you go. Now you got it. Okay, so can you take the square root of 2?
No.
No, so it's just root 2, right?
Mm-hmm.
Can you take the square root of X squared?
Yeah.
It's X, right? So what you have
So
is
it's
that.
2X.
Oh, close. It's root 2X. So it's X root 2.
Oh. Okay.
Okay, right? So this would be X root 2. And now we have the three sides of our 45, 45, 90 triangle.
Alright.
Okay? Okay, what I have drawn on the board now is an equilateral triangle. I know it's equilateral because I got those three dashes. So just like the last one, we're going to pick special angles. And do you remember what the equilateral triangle, what the angle measures are?
30.
Well, no, remember, it's an equilateral, so they all are the same
60.
angle. And so they have to be 60 because it has to add up to 180. So 60-degree angles, and each side I'll call X long because I don't know how long it is. Well, that's not incredibly interesting because I don't have a right triangle yet, so I can't do any trig, right?
Mm-hmm.
So I'll go like this.
So you make a right triangle.
Now I make a right triangle. And what's this angle up here now?
30.
Right, so what I have now is a 30, 60, 90 triangle.
And that.
Okay? So, if that's 30, 60, 90, this side, the hypotenuse is X, right?
Mm-hmm.
So, how long is this side? If this was also X, then this is half of X.
True.
Right? Because I cut the side in half. Now I have to use Pythagorean theorem to find the third side.
Alright.
This is where it gets a little complicated. Okay, we know that X squared, because it's the hypotenuse, equals X over 2 squared.
So you mean this side is the third side?
Well, this is, no, this side, the red side.
Oh, this side.
The height, yeah.
So you're
Because
trying
there's a right triangle. I'm trying to find this side.
So it's X squared.
Well, this is X squared. I'm using Pythagorean's theorem. This squared plus this squared equals this squared.
Oh, alright.
Okay? So X plus 2 squared is, and then the unknown side, I'll call it H. No, H is bad because it looks like the hypotenuse. I'll just call it B squared. Okay? Well, X squared is X squared. We need to find what B is.
Alright.
Okay? So we have X squared and X squared over 2. So we have X squared equals X squared over 4 plus B squared. Okay? So we have to subtract from both sides. Right? To get the B by itself. These two cancel out.
Alright. So x squared over 4 is still.
Well, this is like 4x squared over 4, right? Common denominator.
Wait, I don't see what you did there.
I had to change this to something that would combine with this one, and they have to have a common denominator.
All right.
Okay? So 4x squared over 4 minus x is 3x squared over 4 equals b squared. Okay, because these cancel out. so
Whoa,
it's left
whoa,
as b squared.
slow down, slow down. Let's just go back. Like, let's go back up here. Like, I was wondering, like, what happened here with the negative sign? Like, you are right. You go a little bit fast.
X
It's probably
squared
all that
over
college
4
education.
Plus b squared. I'm just going to rearrange this. B squared is x squared.
All right.
All right, because I just squared that. Now I minus x squared over 4. And then minus x squared over 4.
So we need
So
to find a way
these
to-
two are just cancel out. And all I'm left with is b squared.
So on this side, we
On
just
that
have
side,
b squared.
we just have
so
b squared.
how do we combine these two?
Well, you have to change this into something that has a 4 on the bottom. Common denominators is how you subtract fractions.
All right.
So if I just, this
That's
is right,
already right. Like,
right now it's a 1.
one.
okay? If I change this to a 4, that means I multiply it by 4, right? So I have
So
to
that
also
means-
multiply this times 4.
All right.
Now I have 4 minus 1, right? 4x squared is minus 1x squared,
There's 3x squared.
and the common denominator stays.
All right, that makes sense.
So b squared equals 3x squared over 4. That just brought it down.
Yeah.
Now I have to do this.
So that's the hard part. The fraction and a
It's easy. You just take the square root of the top and the square root of the bottom. I can take the square root of the x squared, right? That's just x. Can't take the square root of the 3, so it's root 3.
So what about the 4?
I can take a square root of 4. What is it?
2.
So this side is x root 3 over 2. So that I have the 3 sides of my 30, 60, 90 triangle are x is the hypotenuse, x root 3 over 2, so we can see it, is the height, and x over 2 is the base. Okay, so now we're going to find the trig functions for 30 degrees, because the other two important angles, I told you 45 is one of them. The other two important angles are 30 and 60. So if we find the sine, cosine, and tangent for 30, and the sine, cosine, and tangent for 60, we can get the everything else we need. So sine of 30. Now sine is, again, opposite over
Hypotenuse.
hypotenuse. Or in this case, it's going to be the opposite side, the side opposite 30 is x over, not x squared, x over 2 over, and then what's the hypotenuse? X. Okay, and this is like x over 1, right?
Mhm.
So in order to divide the fractions, we have to flip and multiply. So that's like x over 2 times 1 over x, right? X's cancel. What's left is 1/2. The sine of 30 degrees is 1/2.
Okay, I get that.
Cosine 30 degrees, this is where it gets a little harder, is the adjacent over the hypotenuse. So in this case, it's x root 3 over 2 over x, the adjacent hypotenuse. So over x over 1, right? So again, same thing. That's the same thing as times 1 over x. Okay? So that becomes, oh, now the x's cancel again. What I'm left with is root 3 over 2. for the sine of 30, for the cosine of 30. Make sense?
Yeah. So what you're doing is like getting rid of common things. Like
Yeah, if there's one's on the top and one's on the bottom, I can just cross them out. As long as you're multiplying them together.
all right.
Okay, so we'll do the same thing for tangent. That's opposite over adjacent. So that's x over 2. And I'm just going to skip the dividing part step and just do times and take the reciprocal of the adjacent side. So that's going to be 2 over x root 3. So what can I cross out now?
X and X.
Yeah, x and x. What else?
2 and 2.
2. So this
So we
is
have 1
1,
over root 3.
but I can't leave that, can I?
No.
What do I got to do?
Multiply it by root 3 and root 3
Right, so that gives me root 3
over 3.
over 3. So the tangent of 30 is root 3 over 3.
All right.
The other 3 you get just by flipping. So I'm not going to say them out loud. I'm going to put it up in a chart at the end of a lesson. All right, now we're going to do the last thing we're going to do right now is we're going to find this stuff for 60 degrees. I'm just going to find the sine, the cosine, and the tangent. We'll put up a chart after we're done of the other ones. And I'll try them just like I did last time. So sine 60. Okay, oops, I erased something I shouldn't have erased. I'm going to remember to turn that off. X root 3 over 2. X root 3 over 2. Okay. So 60 is similar because you have the same numbers, but they're just in a little bit of a different order. So 60, instead of x root 3 over, the opposite is x root 3 over 2. So x root 3 over 2. And what's the adjacent? What's the hypotenuse?
So
instead of,
it's
but on
x over
times.
1.
So it's, well, it would be x over 1.
So
but
2x.
1 over x, because I have to flip it when I divide. Because remember, this is dividing.
Mm-hmm.
I'll write it down. See, this is why I have students involved, because I need to know when I do something that doesn't make any sense. Okay.
Since when we started? Oh, all right.
Okay. So that becomes times 1 over x. What cancels now?
Okay, so x and x.
X and x.
And that's it.
That's it, right? So that leaves us with root 3 over 2. Which we've seen before, correct? Right? Root 3 over 2 is also the cosine of 30 degrees. Okay? Keep that in your head. Because now we're going to do the cosine of 60, which is
The sine.
So it will be, but what's the adjacent? It's adjacent over hypotenuse. So it's x over 2 over x, which is like times 1 over x.
Yeah, same thing.
1/2, which was the sine of 30, right?
Mm-hmm.
Now tangent 60, that's a little bit different. That's opposite.
Over. Opposite over adjacent.
Opposite over adjacent, great. So we have x root 3 over 2 over x over 2, right? That's really times 2 over x. X is canceled, 2 is canceled. All that's left is the root 3.
That makes sense. Perfect sense.
Okay? So what you would notice, and you might have noticed if I said this before, the tangent of 60 is the same as the cotangent of 30. So you see how 60 and 30, that's where we have, remember we did last time, the cofunctions when the angles added up to 90, right? Well, if the angles add up to 90, so the sine of 60 is the same as the cosine of 30.
The sine of 60 is the same as the cosine of 30.
Right. Because that was just like our cofunction.
And the cosine of 60 is the sine.
Exactly. And also the cosecant of 60 is a secant of 30.
Yeah.
The cofunctions.
So it's just like mismatch.
A lot of mismatch. But what we're going to do now is I'm going to put up the table. It's like the most important table. It has to be in your notes. I will probably let you use it on the test. There is a point on the next test where you have to do the work without a calculator. So you need to have this table. So I'm going to put up the table now, and that's going to be the end of the notes. Okay? So see you in class. Say goodbye.